And we are live. Hello, everyone. Thanks for joining us in another one of our events. We're going to have a great talk by Paul. Really appreciate you doing this, Paul. And before we get started, I'm just going to make a few announcements. I'm just going to share my screen here. Okay, so if you're new to the Java user group in Charlotte, this is all the places where you can find us in social media. I will recommend you to follow us on Twitter if you're using Twitter. Subscribe to our channel. So this talk, it's streamed real time, but if you're not able to make it or you need to drop the stream, you can find the videos there. We have already some of our past events there. We have our website where you can also find the upcoming events and also more information in the future. And also, you can reach out to us at info@cltjug.org, and we will appreciate any type of feedback, anything that this community is made by every one of you, and we want to make it better for you. So if there's anything that you would like to hear, any topic or any suggestion, if you think about a different format, especially in these times where we're doing everything online, let us know. We have a few ideas, but we would love to hear from you. Any suggestions? For those that stay at the end of this talk, our sponsors, JetBrains, provide us a license, a 1-year license for a single product. If you're not familiar with JetBrains, they develop a lot of IDEs for most of the programming languages. They are all great. If you are a Java developer, you might have heard of IntelliJ. It's a great product, but if you already have IntelliJ, you can get a license for any of the other products like DataGrip, which is the SQL client, which is great. I love it. So stay tuned till the end of the talk, and we're going to raffle. And the way this is going to work is that Paul will make a question related to the talk, so pay attention to it. And whoever answers first in the live chat on YouTube gets the license. Also, we will be monitoring the live chat. So if you have any question, just shoot it there. If you can prefix it with a Q column, so we can identify the questions versus any other comments, that will help us, but not required. And without further ado, I'll pass it over to Paul. I'll stop presenting, Paul, and you can present your presentation.
Got it?
Yep.
Okay, great. Well, thanks, Orlando, for asking me to do this. We actually planned to do this over a year ago, if I recall, when the Jug was at Lending Tree. But I left Charlotte, and it sort of went on ice. But then I think the world moving remote has sort of resurrected the idea here. Mailinator is a project that I started in 2003. And the idea started, I think I was out drinking with my friend Jack, who, after we were talking about startup ideas back in those days, he had this idea that said there should be a website that accepts email for any address. And I was like, well, we already have that. We have Yahoo, or we have Hotmail. And notice I didn't say Gmail because it's like 2003, so it's probably pre-Gmail. And he said, no, any address. Just no accounts, no sign up, just accepts email for anything. And that's really the right way to think about Mailinator. It's not a webmail system, which you think about webmail systems with accounts and passwords and logins and all the rest of it. Mailinator is a website that accepts email, and it accepts email for any address at mailinator.com. So as you can see, that's billions, trillions, quadrillions. It's lots and lots and lots of possible addresses. It's many trillions of addresses. I think you can have an email address up to like 50 characters or whatever it is. Obviously, the alphabet's 26, so 26 to the whatever your factorial going on is there. It's a very, 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 very large number. and every single address already exists. Now, you can think of it that way, or you can think of every single inbox exists when an email arrives for it. However you want to think about that, it works. That way it works. There's no user accounts. No one owns an inbox. They're all public. You can read any email you want at Mailinator. You can view any inbox you wish. Throughout this talk, and I'll exercise a little bit of caution. Obviously, the anonymous internet is sometimes a scary place. So if you go to a popular inbox like Joe or Fred or something like that, be prepared to see things you may not want to see, in the family-oriented internet. So everything is basically out there. Again, no security, no sign up, no login. Another big deal is it's receive only. We used to get a lot of complaints about people getting bad emails from Mailinator. That's not possible. Mailinator doesn't send email. You can forge a reply to. That's easy. You guys can forge a reply to from any one of you and send it to whoever you want, but they can't actually send there. And then also no attachments. That's obviously really important on the anonymous internet. Very bad things live in attachments. So, now Mailinator will display HTML emails, and HTML emails might have links to images in them, but those images are not hosted by Mailinator. Those are just images out on the web that are part of an email. So again, in the public Mailinator system, and you're going to hear me talk about the delineation as we go forward, public and the Mailinator will evolve into having a private system. In the public system, these are definitely the system, the sort of the constraints, no attachments, and all email is deleted after a few hours. So the original use case of this was, you go to someplace like the New York Times, and they say, give us your email, and you can read the article you want to read. And you're thinking, if I give you my email, you're going to spam me forever. So the idea is you right then and there put in Orlando123@mailinator.com and hit enter. You don't go to Mailinator first, you put that into New York Times first. They then email Mailinator. You then go over to the Mailinator site. It says, what inbox do you want to check? You type in Orlando123, and there's your email. You click the link, you read the article, you never think about that email address ever again. And they spam it forever. So that's basically the point. You don't have to think about it. As relevant to this talk, like I said, it's a website I started in 2003, and how its technical architecture has evolved through that time. And it's far bigger than just a technical architecture. It's now a full-blown SaaS service with many customers, privacy, security, reliability, and scalability. And I think I can confidently say I had none of those in 2003: privacy, security, reliability, or scalability. And Mailinator has grown over time to be able to obtain those things and been restructured to have those things. So I'll emphasize, this talk is not necessarily a talk about the right way to scale a system. This is a talk about how I did scale a system, and it worked. Okay, but there was a lot of bumps in the road, and this is really a journey, not a destination. I think if I were to redo this entire system today, I'd probably make some different decisions. Maybe not a ton of different decisions, but I'd probably make some different decisions. But I'm also glad I went down, some wrong roads. I think those wrong roads were really, really valuable, and I had a blast all the way through rebuilding these systems, retrying architectures, rebuilding algorithms and data structures. This was my coding side project for the last 17 years, and it's just been a fantastic project as far as that goes for me. So who am I? Until a year ago, I was actually a CTO at LendingTree, and I was very proud. I think I might have some LendingTree folks on the call. I was very proud. I never wrote a line of code at LendingTree. I think they're very thankful I didn't. But of course, I never wanted to be too far away from the keyboard. And almost every weekend, I was still coding Mailinator, right? Because it was my place to. It was a piece of code that mattered, a piece of code that people used and cared about, and it was someplace I could make an impact. I've done a bunch of different startups over my time. I spent some time at Google, LinkedIn, and actually I did a PhD in compilers a while back. I've sort of grown more into server architecture since then. So when I first implemented Mailinator, I just looked up some documentation on SendMail, and I already knew Java, and pretty much configured it inside of a weekend. It's pretty easy. You take SendMail, install it. I gave you the command to put, or the configuration for your virtual user table. Just say @mailinator.com, catch all inbox. And SendMail will then accept email for any address at the domain you give it, in this case, mailinator.com. I wrote a nice little Java library with, I think it was IMAP on top of it. Maybe it was straight mailbox. put it on top of Tomcat, coded up a terrible UI. I'm very good at terrible UIs. Rented a server at Server Beach. And I actually found my notes from back then. So that's actually the exact specifications of the server I rented. And this was not some, virtual server or some container in a virtual server. This was actual real metal, at the time. You could actually rent real computers in those days. And that's exactly what that was. And the system would store only the 20,000 most recent emails. Even then, I had a realization that, we don't have infinite storage. Most of the email we're getting is probably going to be junk. So we need a system to be able to take an email in and push email out. So basically, from day one, it had a FIFO queue of basically size 20,000 at the time. The interesting thing about that is, think about every time we get an email now, we have to do two things. One, insert the new email into the disk somewhere, somehow into the queue, and remove an old one. So there's at least two disk hits. There's two accesses of the storage, for any given email. And that really became sort of integral to the decisions about the architecture as we went forward. So this is one of my original diagrams of how the system worked. I had a Java Tomcat JVM running that connected to SendMail. It opened port 80 for incoming web traffic. Notice I don't say port 443. I'm not kidding. There was no 443 at that time. And then I opened port 25 for the MX record for SMTP. And they were in the same JVM. It opened two ports and it was the same thing. There were no separation of services. There were no separate servers. There were no, they were all just there, right? I mean, there was two processes here actually, though, in this initial incarnation. Like I said, Java being one and SendMail being the other. So I knew Joel Spolsky at the time, and he had, if you don't know Joel, he's got a very popular blog, or at least he used to, and he posted on his blog about the launch of Mailinator when I launched it. And I found his post July 23rd, 2003. There was the original look of the website, and it was in those days it was really about avoiding spam. Spam was a very big deal. We don't talk about it as much as anymore, but it was a big deal to avoid spam. And in pardon me, the original motto was something like "flick a booger at spam." In the lower left, there's some sort of boogery little GIF there or whatever else. But it was really sort of this simple and fun site, right? And that was really about it. It was just build something because everybody else was. So the moment I launched it and got 6,000 users, I started getting a few thousand emails in the first day or couple days or whatever else. There was a couple things I learned immediately. Certainly back then, and still to this day, the world tends to think of email addresses as somewhat being identity. And the world is wrong, right? We all have multiple email addresses. They probably all don't have your name on it, right? And I don't mean you're impersonating Bill Gates or something. Maybe you're, Red Stalker from World of Warcraft or something like that at yahoo.com. We've all got those extra email addresses, and there is no identity attached to those. So what I saw right away was that people would sign up. They didn't try to impersonate so much, but they just realized they could get so many different email addresses and sign up for services or vote for bands. There was, vote for your favorite band, give us your email, and you can vote by email. And they're like, great, I got an infinite number of email addresses. I'll vote for my favorite band. So that was I have been educating the internet ever since to say email addresses don't equal people. They're just email addresses. And I think Mailinator really threw that idea in the forefront. The other thing I learned very quickly was if you're building a website and you're developing a sign-up system, you have an immediate decision to make. One is, do I allow people to sign up with their email address, or do I allow people to sign up with their username, right? And it's rare to find the username signups these days. Reddit, I can think of as a specific example that still has sign up via username. But when you do sign up via email, what most people do, most developers will do, is figure, well, people have an email address or two, they can't sign up too many times, right? And if they want a new email address, it takes a minute to get a new email address. In other words, they were basically treating email addresses as a human rate limiter on the internet, because email takes a little time to create. Well, we got rid of that idea. And those websites are wrong too. We gave you, no, email addresses are free and infinite now. You can have all you want infinitely and free. Incidentally, if you go to Reddit and try to sign up for, you go to sign up for 2 or 3 or 4 accounts, they'll shut you down immediately. They didn't make that assumption. They know people want to make 10,000 accounts, so they implemented their own rate limiters. So what I often see in sign-up sheets is there's no concept of a rate limiter because you don't need to, because you can't get that many emails that fast. So what the world has done largely instead is, in many cases, tried to ban disposable email sites like Mailinator, and I'll talk about that a little later, which is, it's sort of a war of attrition in all of its own way. So I ended up spending some large portion of the history of Mailinator writing anti-abuse rate limiting code. The idea that people treated getting an email address as a rate limiter really was not my fault. However, when they woke up in the morning and found 10,000 new accounts on their website, they were all junk, they wanted to be mad at somebody. Now, they don't know who did that, so they can't be mad at that person. So the most logical next person to be mad at was me. So to limit my own abuse and my own grief, I put in a lot of anti-abuse rate limiting code, which still exists to this day. You can only read emails so fast. You can only read, the entire system will only allow so many of the same subject to be read in a given day. So there's all kinds of rate limiting stuff inside the system. And that became a very big piece of what I had to build inside of Mailinator. So as far as system limitations, what I learned, we grew very quickly. And keep in mind, when you use a Mailinator address, you then go away and never use it again, but it continues to get spammed forever, right? So right now, the current use of Mailinator is about 40,000 users per day, unique users per day. And that translates somewhere, it's very variable, but somewhere between like 3 and 10 million emails per day. And those 3 and 10 million emails, most of them, needless to say, are never read because they're old, they're on spam lists and they've been cycled and cycled and they just keep getting junk forever. So one thing I like to always say is both good and bad software engineers build systems that eventually crash under load, but the good ones can tell you where it'll happen first. And I was certainly not that guy in 2003. But if you do some quick back of the envelope math here, disk seek times in the early 2000s were 10 milliseconds, right? So you basically could do 100 of those inside a second. So 100 disk seeks. Now I'm going to talk about, writing data. I'm talking about disk seeking, 100 of those inside of a second. Each incoming email requires 1 write and 1 delete, right? It's a FIFO queue, so we had to move the queue. So we can do 50 emails per second, sort of by definition. And this is being extremely hand-wavy. I say that I'm hand-waving over many disk seeks, right? We're popping through B trees, we're doing indexing, we're doing all kinds of other stuff. So it's actually way more than 2 disk seeks is our cost to write an email to the disk. But in a hand-wavy pattern, that's about all we could possibly do. Also, I thought about, is there any possibility of caching here? And no, this is about the worst LRU caching situation you could ever think of. An email comes in, has about a 1%, probably way less than 1% chance of ever being looked at, waits for 20,000 emails to come in behind it, and it leaves. There's nothing to cache. It just literally made no sense to cache anything in this entire system. So what I started noticing, and maybe we're a year or two later now from 2003, the system started to crash at about 800,000 emails per day. And that's about 9.3 per second. Note that whenever I'm talking about scaling and systems here, user activity is basically irrelevant. The activity and the load that humans put on the system just don't factor into what I was working on as far as scaling a system. It's all about that email volume. So as is often the case, disk was the problem. So as I said in the last slide, you can hand wave a disk seek in 2003 at about 10 milliseconds. You can hand wave an SSD seek nowadays about 65 microseconds. If you'd start Mailinator today, you obviously can scale far farther with that original architecture just because you're an order of magnitude faster on the SSD. But memory is accessed in nanoseconds. So you have disks in milliseconds, SSDs in microseconds, and memory access in nanoseconds. So I thought, let's put the email in memory, right? So I think I was at Google about this time, and one of the things that struck me was they kept the entire web index in RAM. So you do a Google search, your query goes out to about 6,000 machines, it all hits their RAM indexes, comes back and gives you a 50 millisecond result. So I said, can I store all this email in RAM? So I did the quick math there. An average email is about 4K, 20,000 emails times 4K, about 80 megabytes. but I've got a lot of indexing to do. I've got a lot of emails to store. Java isn't very known for its memory frugality. Incidentally, this system has been Java since day one. It's still Java today, obviously through many incarnations and many releases. So I estimated about 130 megabytes would be required to store 20,000 emails. So the first thing I found was that there's no mail servers out there that store the mail in RAM. They all want to store it in disk for some, weird reason. So I said, okay, cool. And as you'll see in a theme throughout this talk in Mailinator, I built my own SMTP server because why not, right? And needless to say, anytime I built any one of these pieces of infrastructure, I was probably not the guy qualified to write one of these pieces of infrastructure, but certainly don't let that stop me. What I learned was SMTP was a very, very chatty protocol. If you think of an HTTP request, it basically says, give me a web page, here you go. Give me an image, here you go. That's really sort of the, there's a lot of complications in future versions, but that's really a base core HTTP transaction. An SMTP transaction is at least 5 commands. Hello, hello, mails from Bob, okay, mails to Joe, okay, here's the mail, okay, goodbye, goodbye. 5 back and forths. So if I were to say we were doing 10 emails per second, you're really talking about 50 messages per second, and typically even more. So I built a SMTP server. I was actually get the code that handle all the commands and stuff from someplace else, but it was a multi-threaded blocking synchronous server that could handle at the time 300 simultaneous threads. I don't know why I picked that number, but I did. And I've talked many, many times over the years about rewriting that in asynchronous fashion, and I've yet to find a reason to do it. So today, Mailinator is still, the SMTP servers are still a Java SMTP server running anywhere up to about 10,000 threads simultaneously. And there's a huge, wonderful argument in the world about asynchronous versus synchronous coding. And I don't regret that decision at all. And it's worked to this day, and I don't see it changing anytime soon. Oh, and I also, by the way, at the time I deployed this, I was hosting at Server Beach, and they had a sale that I could get more RAM, so I splurged and got myself a 2 gig server because what the heck, you never know if you need it. So the diagram gets a little bit more complicated now. No more send mail, but you've got one JVM, you've got an SMTP server running in there, you got a web server running in there, and they're both looking at the exact same heap, right? So you're storing everything inside that heap right there. And this diagram, again, is from 2005 or something like that. And I said lots of memory because it was just, a bunch of lots of memory. The side effect, of course, of storing in RAM is that when the server came down for a software upgrade, all the email was lost, right? And I was like, hey, it's a free service. Yeah, all the emails lost. In fact, Mailinator would run in a screen, which a screen is a detached SSH session. And more than once, I would have a browser up on my window, on my screen, and the Mailinator server scrolling past some diagnostics on the other screen, and go to cut and paste something in the browser window, be in the wrong window, press Control-C, and destroy Mailinator along with all of its emails right in the middle of the day. But again, hey, it was a free service. These are the kinds of things you can get away with a free service, effectively. So one of the problems that I kept revisiting, and I have probably rewritten this code a dozen times over 17 years with some pretty radical decisions and thought processes. How do you store these emails, right? I mean, you could just dump them into RAM, and that's fine. But there's also this concept of how do you index them, how do you FIFO them, and how do you deal with thousands of threads all attacking them all basically at the same time. So there's a nice little set of constraints here that we had to have. They have to keep ordering. You have to know what email came first and what email came last because it's a FIFO. Then you had to be able to look up emails by inbox. So if I say Joe, I want to see all the emails for Joe. And I also have to look at email by ID so I could look up, the very specific email. So if you were doing this in a database, this is dead simple. You got a couple columns, the message ID, when it was received, who it was to, who it was from, the subject, the email body, and then you have at least 2 of these columns or indexes. And I can look up by, a non-unique to index, or I can look up by a unique ID and get what I need. And database does a ton of magic for you. How do you do this in memory with data structure? So this is where, again, I've rewritten this system many, many times. Now, part of the interesting thing is I really wanted to write this for the data use case. You know, if you say to someone, what's the fastest sort in the world? Well, it's linear, right? If I know the data is already sorted, I can tell you I can do it in linear. In fact, if it's data, I can do it in constant time. If the data is already sorted, I can just say, yep, it's sorted and walk away, right? If you know your data and your use case, I can tailor the data structures and the algorithms to work better for them. So if you look in the upper right, these are the use case of how this data is worked. Inboxes are fetched at a rate of hundreds per minute. Fetching of emails happens at a rate of tens per minute. Adding of emails is thousands per second. And adding an email also means deleting an email, right? So you can basically double that. And then a user deleting an email is like ones per minute. So clearly the optimal use case, what I'm optimizing for is adding of email. That's what really matters here as far as what's going to dictate how this data structure should matter. And you notice I have a bunch of hash maps here. Typically when they measure hash map performance, you'll see something like, oh, it's 80% reads and 20% writes, or 90% reads and 10% writes. That is completely not my use case. My use case is about 98% writes and deletes, which is arguably a write, and then 2% reads. So again, I'm completely turning these data structures on their head. So this is one incarnation. I'm not sure if this is the latest incarnation, but it's one of the incarnations I implemented, which the hash map on the left allows you to look up inboxes by inbox name. The hash map on the right goes by message ID, and then there is a massive linked list which keeps the emails in order. And obviously, if you want something in order, a list is part of it, whether it's an array list or linked list or something. But a list is the sort of the canonical way to keep ordering. So these are all being hit by thousands of threads simultaneously. So we need several mutexes. I was very into multi-threaded programming at the time. I had a great time organizing these structures to basically get that storage to work. Again, if you look here about the further considerations of memory organization, the inboxes had hundreds of thousands of entries. The email IDs had millions of entries. So therefore, the email linked list had millions of entries. What I ended up writing in this, if you look at the very last line, a data structure called a synchronized linked tree map. If you're familiar with Java, you're familiar with the tree map. You're probably familiar with a linked hash map. You're certainly familiar with synchronized map. And this would make a great interview question, by the way. Java, if you can say anything else about Java, when you got a data structure like this, it tells you so much about what this data structure is there to do, right? So synchronized tells me I got a lot of threads hitting this, or when by a lot, I mean 2 or more. If it's 2 or more, it might as well be a billion because you got to synchronize it, right? Then the map is linked. So that tells the user or the other developer that I care about ordering, right? So linked implies we care about ordering. Then it's a tree map. Okay, wait a minute. No, we don't use tree maps hardly ever. We use hash maps. Why are we using tree maps? Do we somehow feel that a log n lookup time is going to be more interesting than an amortized constant lookup time? Well, there's several reasons for the tree map. The primary one is the tree map allowed me to do sub-range queries. So basically now in the Mailinator system, you can look up an inbox, and I don't allow this in the public site, so sorry if you go try it, but it works inside the system, is you can search for all messages in the Joe inbox. But you can also search for all messages in the Joe star inbox. And it'll give you any inbox that starts with the word Joe, right? Or test star or whatever else. And actually paid subscribers right now can do that inside their version of the product. But you can search for any inbox with any sort of prefix you want. And tree map enabled that. And of course, the performance difference between tree map and hash map isn't going to be significant. So this is where we sort of ended up. Question I would always get is, what about compressing emails? Well, there was a bit of a problem with being CPU intensive, especially in the early days. I did a ton of experimentation with this using some really strong algorithms, 7-zip and stuff like that. But it turns out it didn't work very well. First of all, when email traffic got really high, the CPUs would max out, and that's obviously a problem. Right now, the CPUs are basically not even turned on. They're very not busy. They're just storing memory here and there. But compression algorithms didn't work very well either. Compression algorithms typically work by scanning data as they go along and building a dictionary. Emails are often too short to build a really good one, and they're very variable. They start with headers that are like broken and weird. And then they, the email body is not just text. It's got all kinds of borders and all kinds of other weird email stuff. I'll show you an email in a second. And then you get stuff like base64 encoded emails, which just aren't going to compress at all. So I found compression to be very dubious. And at one point I realized the headers at least were key value pairs. I could build a Huffman encoder for the keys, and that actually fit into the thing that the category of something I spent 2 months on, got way down the rabbit hole, and finally said, this isn't going to work, and never did that either. So then it occurred to me at some point to reuse email. So here's an actual sort of a representative email as it looks in text. At the top, you've got a bunch of key value headers. The left side is from, date, subject to are very standard. The right side is extremely variable. You can't count on anything there. Then you'll notice the email is broken up into different parts. And that's what made it tough to compress those. However, what we would see is 10,000 or 100,000 of the exact same email. They'd have different headers because they went to different inboxes. They came at different times and things like that. But the bodies would be exactly the same. Because what happened, we got 10,000 of our email addresses on a newsletter list, and they all came at once, right? Or some, Louis Vuitton spam or something like that. We'd get all these same emails at once. So what I ended up doing with that was basically creating a fast hashing algorithm that would break up headers and email bodies, scan the email bodies for that hash, and decide if we can restore that email body or reuse one that's already stored. They say when you buy a song on Amazon or wherever you buy it from, you don't get your own copy on disk, right? Everybody's listening to the same file. There's one copy of Pink Floyd The Wall on some disk. I'm sure there's backups, but one copy out there that we're all listening to. And this is the same thing here. You can go to 50 different inboxes on Mailinator, read 50 different emails, and you're actually looking at the exact same piece of data that came from memory. So this was a very extremely useful way to not compress, but reuse data. And this didn't apply to the headers because they were just too variable. Okay, great. So we've rewritten our SMTP server. We're going to launch this thing. I launch it. Everything's going great. The system went from crashing at 800,000 emails a day to running rock solid at 1 million emails a day. The disk turned off. No surprise. I'm literally storing nothing on the disk anymore, right? So the disk is just completely not busy at all. The CPU is also not busy at all. This is fantastic. So it was fantastic, but something started to bother me. After a few months of this, I kept noting, remember, we weren't getting past 800,000 emails a day before this. Now we're getting to 1 million, that's just a little bit more, and we sort of plateaued. Like, it seemed too consistent. Like, we never really went under 1 million either. We never really went over. There's nothing magic about 1 million. It's not a power of 2. There's just no reason why the system would hang at getting about 1 million emails a day. Now, the site seemed pretty slow, and I probably just blamed that on my HTML. And customers kept complaining that their emails didn't arrive. But yeah, but why did I even use the word customers? It's not customers, they're users. What do users know, right? So I just sort of blew this all off. And for a while, months, maybe, I don't think a year, but months, maybe. But then at one point, Server Beach had another sale. And they said, hey, do you want to upgrade your 10 megabyte network card to 100 megabit per second network card? I said, sure. So as soon as we upgraded the server, we immediately went to 3 million emails a day. So what had been happening in that old server, we were previously bottlenecking on the disk. We got rid of the disk bottleneck, and we immediately went to a network bottleneck, and we're saturating a 10 megabit per second card. So it couldn't get past roughly 1 million emails a day, basically. And we immediately went to 3 million, and it became variable. Some days 2.5, some days 5, just all over the place, right? Every system has a bottleneck, and this was a really good example of moving that. Now, this experience scarred me a little bit. So some of my design decisions going forward were very much about respecting that email amount. There's just so much email, we have to respect that. So a few things I learned: every user or email that hits your system is basically a part of a denial of service attack. They might be users or customers, but they're also denial of servicing your system. It's much harder to DOS your system if the request hits only RAM and CPU. And it's quite easy to DOS your system if your request hits a disk, right? If you are doing a database write on a web page load, just run Apache Bench against your site and watch it go down, basically. Two other things that I learned by writing my own SMTP server SMTP servers have this little feature typically that say, I'm sending an email to, paul@gmail.com, and Google says, yes, we accept email for gmail.com. Good, here you go, and puts the email in there. Now, if I sent to Google's SMTP servers, hi, I want to send you an email for paul@microsoft.com, Google's server is going to say, I don't accept email from microsoft.com. Go away and throw it away. I forgot that if statement when I wrote the SMTP server. So I never checked that Mailinator email coming to the Mailinator servers was addressed to Mailinator. I just said, if it's coming here, we'll take it. So at first I thought this was a bug, and then I realized, no, this is a feature. So I wrote a blog article that says, want your own private Mailinator? Point any domain you have, actually just the MX record, to our MX servers, and your email will arrive just fine. So say you own mounteverest.com. You can point the MX record of mounteverest.com to the Mailinator servers, and then you can use Joe at Mount Everest, and Bob and Fred and Orlando 1, 2. You can use anything you want, and it will arrive in Mailinator inboxes. Last time I checked, I gave a URL there. About 1,900 domains have pointed their MX records to us. So we get email for all those different domains. To security researchers, by the way, this looks like an open relay. Security researchers kept emailing me back in the day, expecting to see that rejection message to say, you're Mailinator, but you're accepting email for yahoo.com. You're an open relay. Spammers love that. And I'm like, no, I'm not an open relay. I accept the email and put it in an inbox. And they said, well, if you keep doing this, we're going to put you on every spam list and no one will accept email from Mailinator. I'm like, well, Mailinator can't send email. Okay, that's another feature. Good. I don't want anybody to accept email from Mailinator because that's a forged email, and someone's just going to get mad at me about it. So that was 2 features via bugs right off the bat. So again, everything is great. We're still running on a single server, a few million emails a day, a few thousand users per day. And then I went on vacation for a week. And during that time, I had one of those hardware failures that doesn't just crash the system, it just flakes the system out. So the system sort of kept just rebooting and kept crashing and all the rest of it. Those are worst. If the hard disk is bad, that's one thing, you just go replace it. But this was one of those terrible ones that sort of just flaked the system out. So I realized I needed to make the system redundant. So here's where we were, right? This JVM with these 2 things in it. And here's where I'm going to break it apart. So first of all, I set up 2 web servers, and I load balance those with HA Proxy. If you don't know HA Proxy, it's a fantastic lightweight load balancer that load balances a lot of stuff. But I'm using it here for web traffic. And then I got 2 SMTP servers. Now, I haven't connected them yet. I'll do that in a second. But the one thing I was really excited about was, unlike regular sort of records for web, MX records allow multiple entries. So I was thinking, this is perfect. I can set an MX record for each of my SMTP servers, and the traffic will just naturally load balance. This will be awesome. And I was really excited about that. It didn't quite work out that way. But again, I'll show you that in a second. So I wanted to figure out how to connect these 2 things. And one of the suggestions I got right away was, well, put a repository for the email. You can stick in RAM, so we can use Memcache or Redis, or use Mongo to a RAM disk. And you can do that. The web servers can read from there, and the SMTP servers can write to there. But this made me feel really bad in a lot of ways. Now, first thing you can say about, if you're ever looking at an architectural diagram and you want to gauge its scaling, look at HA Proxy. There's 2 arrows going outward. That's a splitting of traffic, right? So that's telling you we're scaling in some sense. Those 2 SMTP servers, they have 2 arrows going to one place. That's an aggregation of traffic. So you're not scaling right there. So that part I didn't like at all with this idea altogether. Then second of all, we have all that email coming in to say SMTP1, but then it's going out again to the database or the store in one way or again. We're basically doubling the traffic. Now, those are probably different NICs these days. Back in 2003 or 2005, it might not have been. It might have been the same network card and that sort of thing. So I was still not too happy about this entire thing. In fact, I realized the fact that most emails not read. So why would I have it cause any more damage than it possibly could? And I decided to say the email is going to stay in the SMTP server. I'm going to use the heap of the SMTP server to store all email. Therefore, every web server needs to talk to every SMTP server. And at first, I found this to be a daunting prospect. Turned out to be not a big deal at all. Okay, so this is the base architecture today, or as it was in 2010. And we basically have the web servers just talking to SMTP servers. And when I have up there, what happens in the SMTP server stays in the SMTP server, right? That traffic doesn't leave. So it constantly working inside those SMTP servers to receive the email, store it in RAM, purge it when it goes out of the FIFO, and deliver to the web server whenever asked. But that's a rare event compared to the influx of email. So now we also have redundancy, by the way. Obviously, if a web server goes down, SMTP server goes down, we're still okay. We still have a system, right? The problem was now, again, MX didn't do what I wanted. Not to mention, if an SMTP server went down, emails actually still got delivered because typically mailers will retry different MX records, but it took some time. Also, we got denial of service at that time, which, that just happens. So I made a few more changes. First of all, on the left-hand side, you notice now we're behind Cloudflare. So Cloudflare is a wonderful product. If you don't mind Big Brother, they're a fantastic product to be behind. They give you lots of advantages besides DOS protection, but they do give you DOS protection. On the HA proxy, you'll notice I've got a little shadow box behind it. I put in redundant shadowing HA proxies now. So if one HA proxy goes down, another takes over. Also notice I put HA proxies in front of the SMTP server. Like I said, HA proxy is an amazing product. It'll proxy SMTP too. So it would basically load between the two servers. So now no matter where you come in, you get balanced across the system. So now we are really, really stable, comparatively speaking, right? Any one server goes down, we're fine. Any 2 or 3 of the wrong ones and we're in trouble. If Cloudflare goes down, we're down, which they do. I've seen them go down a few times at LendingTree also. But nonetheless, we're in a pretty robust system. One of the problems, though, you run into with multiple servers is service discovery. And there's a lot of tools out there with this. etcd or Consul or Docker has a lot of built-in solutions. I wasn't using any of that. So I found a real simple solution. This was all hosted at Linode, and Linode allowed you to tag your servers. So I had all the servers out there basically query the Linode API and ask for the entire server list and parse the tags. So if I want to set up a new SMTP server, I can fire it up, install the software, get it going, and nothing happens until I add that tag. And the moment I add that tag, all the web servers connect to it and say, hi, you're an SMTP server, give me email. And all the SMTP servers know what web servers are going to connect to it. Also, what I found was this great Java package called JGroups, which is basically a multi-server shared heap. Fantastic product. You can create a hash map and all your servers see that hash map at the same time. But it also allows you to do leader election. So I was able to, for the several batch jobs I had running that would clean up some stuff or this or that, the servers elect a leader and that leader runs all those batch jobs. If that leader goes down, it's a non-event and some other server picks it up and becomes a leader and off it goes. So a couple things to sort of soften the idea of multi-servers. So again, everything is great, right? Only thing down, or anything that brings the system down is me tinkering with the code or trying to cut and paste from my browser in the wrong window, stuff like that. But we kept getting more emails, but not necessarily for system issues. Now we got business users asking for features and enhancements, which I've been trying to monetize this product for probably 5 or 8 years. I mean, not full time or anything. I always had a job, but I never really got what the use case was, and my users found it for me. It turns out quality assurance teams were using this like crazy. Having an infinite number of email addresses turned out to be very handy for testing. Testing your sign up, try Joe1 at mailinator.com, see if your code works. Oh, there was a bug? Okay, try Joe2 at mailinator.com. So it was clear that the customers were already using the product. There's no better testament to you should build a product around this than customers are already using it. So how do we do that? Okay, so the first thing is privacy. In the public Mailinator, there is absolutely positively no privacy. Anybody can read any email, right? And that's fine for signing up the New York Times and reading an article, but it's not fine if I'm a healthcare company sending my test emails to Mailinator. So every subscriber now gets their own private domain. They get basically their own Mailinator system that's private to them, right? Their emails, needless to say, aren't stored in RAM. Oh God, now I have to store them on disk. That's what we got away from in 2003. We got to go back, right? So we got to store these emails somehow on disk. We got to figure that out, right? Then we have now we create a new web interface, and you can see the web interface below, and that looks like a pretty normal email interface, but the real difference is there's a column that says to. In your Gmail, it doesn't have a to column with your email 500 times, right? Because it's always to you. But in Mailinator, it's to a lot of places. You have control of an entire domain of email. Like in that example there, at my company domain, you can use any possible email at my company domain and see it in one single inbox. Also, API access, right? Basically convert SMTP to JSON. Private SMS. We added SMS after a while that you can do testing with SMS and it arrives in your private inbox. A rule system to auto route emails. An email arrives to the Joe inbox, send it to Slack. An email arrives to the Bob inbox, forward it to my Gmail. It arrives to the Sam inbox, auto click all the links. Also, we need sign up, login, forgot your password, uptime guarantees, security, support, API. It's a lot harder to build a company and a product than just a sort of a side project. So here's where we were. Now I add a database. I go ahead and put the database in there. It's just one database with replication. That's a low traffic database that does users and logins. Nothing too particularly fancy about that. But then we go ahead and build a much bigger database. This one stores emails. Again, I'm giving you the idea that it's replicated there. We obviously do backups too, but it's hot replicated across several things. And of course, now we got arrows going to the same place. We introduced a bottleneck. We introduced a scaling problem. So this is the architecture, but what you have to do now is, of course, sharding. And I give a really simple example here. If I have a customer whose last name starts from A through G, they go to one database, H to M goes to another database. And the good news is you can shard this all the time. And if you use a NoSQL database, because they don't typically support joins, this makes it very easy. If you have a very deep SQL database with a ton of joins, this becomes much, much harder. But this is, I don't shard based on this, but I can shard on lots of different things. So although this is our architecture with this sort of bottleneck on a database, and those database entries are still based on a FIFO system per customer, we can now give multiple databases per customer. And I'm happy to shard all day long because that just means I'm getting more customers, and that's a great problem to have. One problem we ran into here quickly was the SMTP servers were shared between private and public emails. So that's fine most of the time, but public is the Wild West, and we would sometimes get extreme traffic over there. So I went ahead and added another private SMTP server that customers point their Memex records to and don't have to deal with the riffraff. And they get so they're completely separate, but the web servers still talk to them. And now you notice we're getting a lot more boxes and a lot more lines, and the architecture is far away from our original one machine with SendMail installed on it. But this is, again, a good representation of how the architecture has sort of grown. So great. Subscribers get their own private Mailinator. Public users still get their public Mailinator. There's a problem here, though. Every single incoming email with all these possible domains, some of them for users, for subscribers, some of them for just people who pointed their domain at us, have to check the database to see if that's a private domain or just a junk domain. So what I did was I wrote replication code. I fool the database into thinking my Java code is yet another replica. So then I replicate the private domain databases in memory. And this is just a couple thousand entries, and even if it grows, it'll only grow to a couple 100,000 if I'm lucky. And that should be perfectly doable. But now it's just hitting a hash map, and we don't get that limitation. Okay, so next problem we had, and keep in mind, we're going over a 17-year span. So all these changes are happening over 17 years after seeing problems, knocking down one roadblock, which then got us to the next roadblock, right? So we kept seeing this. And this is a good example. Let's say we had 2,000 concurrent users and they all go to lunch and they leave the web page open. Well, the original Mailinator, the web browser was polling the back end to go ahead and get email. That's what webmail systems do. They show you when there's new email. Well, even if 2,000 concurrent users are polling inboxes every 5 seconds, that's 24,000 web hits a minute, or 400 per second, for nothing. They're at lunch. They're not even looking. So I realized at the time that we could look at Mailinator in a very different way. You think of webmail as inboxes, but that's not really what Mailinator is. It's much more like Twitter. Inboxes are like Twitter handles. It is a stream of data that is basically flying by. Okay, and when you subscribe to a Twitter handle, you're really just tapping into the stream right at that spot, right? And this is exactly what I said. Why don't users do that for Mailinator inboxes? Subscribe to inboxes. Don't just read the inbox, subscribe to it. right? So let's build WebSockets. Your web browser connects directly to the Mailinator system, and the moment an email arrives, it now flies through the system and appears in your browser. It's actually quite instant. So it's sort of a cool little feature as far as that goes. But I needed a pub subsystem, right? And of course, my initial inclination was I'm going to write my own, which is of course what I did. And I wasted 3 months because pub subsystems turn out to be really hard. And I had a blast, but I didn't use it. I finally just went with Redis, which is what I probably should have done in the beginning, but I'm not bitter. And off we went. So each SMTP server gets its own Redis instance. But we don't send the entire email into Redis. We just send what you'd see in an inbox, the to, from, subject, and date, right? And no data leaves the SMTP server unless that inbox is subscribed to. And Redis is bulletproof, so you really can't knock down Redis as far as that goes. So here's where we were. This is the last place we left this, and we basically just installed a Redis. All that traffic is leaving the SMTP server, going over localhost only, going to Redis, and only leaves the server again if it's subscribed to. So again, everything is great, right? We've got this, and let me show you. I haven't even showed you the site yet. So here's the front page. And if we go ahead and I'll type in Joe, and again, pardon me if you see some, I didn't put the email in here. If you have a delicate temperament, you might not want to read all the subject lines, but off we go. And you can see the emails. I'm not sure how it came across on camera, but they're flying down the screen. That is the WebSocket basically loading them one by one. And you can actually go up here and pause the WebSocket, and it goes red. I did that little green red button all myself. I'm very proud. And then you can say play again, and it goes on. And as emails arrive, they arrive basically instantly. Also, if I can go, I'm actually SSH into one of the SMTP servers here, and I have no idea how it's going to come across like camera, but let's do it for fun. Here's actual traffic coming into an SMTP server in real time. Needless to say, it's 6:50 on a whatever Wednesday night. This is low traffic right now, but there you go. There's a whole bunch of that's how it sort of flies to the system, and it's all wasted. It's never looked at unless somebody subscribes to one of those inboxes. So everything is great. I mean, it seems like everything's great. Everything seems to be running good. Actually, I really have no idea what's going on. I had no monitoring whatsoever. So I wanted to do some system and application monitoring. I did a little research, and I found Elk. Elk is a very popular system, Elasticsearch, Logstash, Kibana. It very much reminds me of MVC, the old acronym, which was always broken. It should have been what? CVM, Client View Model, or VC, whatever it is. Same thing here. It's in the wrong order, but I didn't make up the acronym. So Elasticsearch is a very cool free search engine written in Java. You have to have a pretty big machine because it's a little bit expensive, but you can send data to it about analytics. So that's what I do. Every time we get an email, every time we get something to happen, we send data in there. Now keep in mind, in the public Mailinator, we keep no data basically about user activity. There's no reason to, and it's just a liability in the big picture in the public system. The private system, we keep track of analytics and how often users are using the system, et cetera. We also keep track of a snippet of every email that comes into the system. Not the whole email, just that little snippet you saw in Redis, to, from, subject, and date. But I can show you exact stats of the spam we got today. Okay, Logstash was part of this suite because Logstash is a system that takes log lines, turns them into JSON, and then allows you to put them in Elasticsearch. So I'm thinking like, well, logging is really where you take your structured program data, you've got your variables in memory and all these other things. You put out a log line that says, okay, email received for Joe, and then you put it into unstructured log lines, and then Logstash will restructure. Why am I taking structured data, unstructuring it, and restructure? That sounds dumb. I'm not going to use that. So I just basically built structured data straight out of JSON and sent it to Elasticsearch myself in real time. Then you have Kibana and Grafana, which are basically two front ends for Elasticsearch. They're front ends for lots of things. Kibana is a little more search engine-y, but it's also could do most anything. And Grafana is much more about graphs for analyzing all that data, right? So here's where we left off. Here we have no tracking, but this is our original system. So let's add some tracking. And I go ahead and add two Elk clusters, basically. The one on the left just tracks basically subscriber activity, some system stats, how big, some hash maps are and things like that. The one on the right, though, is much more active. It's keeping track of every single email that enters the system. Again, not the whole emails, just pieces of them. So We flush that data out every 2 weeks or so, but I'm just using it for trends. And we can look at the data. So this is a screenshot of my Grafana server. If you look in the upper left, you'll see it lists 3 SMTP servers, and it shows the number of emails they have stored in RAM. The first one has 1.6K stored in RAM because that one's not a public SMTP server. That is a private SMTP server. It should have nothing stored in RAM, but that shows you who's just haphazardly attaching to that SMTP server and sending it junk, so just a little. The next 2 store about 536,000 emails in RAM each. So Mailinator at this time when this screenshot was taken was storing a little over 1 million emails in RAM. In the next thing over, the last 24 hours, Mailinator had received 7.5 million emails. It delivered about 3.5. And by delivered, the rest were basically dropped on the floor. If it gets, 1 million of the same email, it just starts to throw them away after the first 100,000 or first 10,000 or whatever it is. So it's learned over time, and I should say I did because I'm not trying to pretend there's ML in here, AI or something, but what to keep and what not to keep. So it throws a lot of junk on the floor, and it basically stored 3.5 million in the last 24 hours. In the private systems, we delivered in the last 24 hours 500,000 emails for customers. Those are stored to disk and to database, and the max rate of incoming email the system saw in the last 24 hours was 1,700 emails per second. Typically, like I said, we don't see over about 2,000 or 3,000 threads active at any given moment, and that's not really a big concern. So Mailinator today, it's a team of engineers. We have sales, marketing, and support. It's a little bigger than that. There's a lot of contractors involved. 3 to 10 emails, million emails a day. And just a few years ago, 20 to 30 million was much more common. And I think the spamming landscape has changed. Maybe also the spammers have realized we're not worth wasting their time on. And maybe the marketers have realized we're not worth wasting their time on. Although we still get plenty. Biggest public spike we ever saw was 200 million emails in a day and about 2,000 to 3,000 emails per second. Again, be always very careful with those numbers because if the emails are 50 bytes, I can take a lot more. And if they're 500K, I can take a lot less. So, I mean, it's very hand wavy about how many you say per day. Typically about 30 to 60,000 users per day and over 100 grand when we hit the news. We have thousands of corporate users, millions of API hits a day, all Java, very few frameworks. I'm not a big fan of frameworks. SMTP still the raw socket code. WebSockets, Angular, Mailinator front end, servlet JSPs, all very baseline stuff. No Spring, no frameworks. As much as I could avoid other tools and frameworks, I did. A couple sort of disposable email game stories. I've talked to law enforcement a few times over the years. That happens. And when I started the service, the first criticism I always got was, what if they ban you, right? What if if everybody just says, we're not going to accept any email from mailinator.com? And they did, right? It was a big deal especially in the early days to ban mailinator.com. And at first I took it sort of personal. How do I get around this? Screw you for banning me. So I said, I know, I'm going to create some alternate domains. So I bought, not mailinator.com and reallyMyEmail.com and veryrealemail.com and put this in your spam. All of these also pointed at Mailinator, and I would advertise them on the front page. And I would just show one at a time, and I would often get an email that says, hey, can I get the whole list, your entire list of alternate domain, so I could, use the one I want whenever? And I'm thinking like, yeah, you mean you want the whole list so you can ban the whole list. So no, you're not going to get the whole list. But then I noticed sites would scrape our homepage over and over and over and over and just keep scraping it to get each domain so they could build a database of all of our alternate domains and put them in some database. And I thought, what happens to those domains? So they scrape our page, they find a new Mailinator alternate domain, they put it in some database, and then if someone tries to sign up with that email would get rejected, right? And they wouldn't be able to sign up for whoever service that was. And I think that's interesting. I wonder what would happen if into that database like gmail.com got into that database somehow, like at 2 a.m. on a Sunday morning after a night of drinking, like gmail.com got into there, accept no logins from this email domain got in there. I wonder what would happen. I'm not saying that ever happened, but what if that ever did happen? So anyway, there was a couple years here where I really sort of fought back and cared. But soon after that, I sort of realized this wasn't a war I want to win. This is your site. If you want to ban Mailinator, knock yourself out. That's your business. Personally, I have a primary email account. I have a secondary email account at Yahoo, which I sort of use for semi-junk. And then I use Mailinator for those real junk use cases. And if you don't want to let me use Mailinator to sign up for your service, then I'll probably just go away. And that's cool. That's your prerogative. The only thing I will say is, since Mailinator's come out, there's probably 100 copycat sites of Mailinator at this time. So there's thousands and thousands and thousands of domains you got to block. A lot of time people buy a service for that. But I gave you a link down at the bottom there to GitHub. For 23,000 domains you can block to get you going. The other little thing I learned, and I learned this just recently about this, that I would like you to imagine if you're a developer and your boss comes in and says, hey, I just learned about this Mailinator thing. I want you to ban all signups from mailinator.com. Cool. So you go write some code that looks something like this. If the email domain equals mailinator.com, reject the sign up attempt. Perfect. But remember I told you Mailinator accepts email for any domain, including subdomains of mailinator.com. So not only does Mailinator accept email for anything you want at mailinator.com, it also accepts email for anything you want at anythingyouwant.mailinator.com. And to my surprise, probably 90% of the sites I found that ban Mailinator don't ban a subdomain of Mailinator. So there's a little immediate workaround. If you want to write the code correctly, by the way, don't use equals, use ends with. Little defensive programming lesson for the folks out there. So that's what I have. Thank you very much. Like I said, Mailinator's been a journey, not a destination. And I've been enjoying lately working on it full time as turning it into a real business, and it's moving forward.
That was awesome. Let's get back to this screen. Okay. Well, thanks a lot, Paul. That was really good conversation. Let me see if no questions? Come on, guys. Well, I have one question for you. This is really interesting. I know your talk is, and this is my understanding, that the intent was to show the evolution of your architecture, and it definitely shows. But I also like the product type of evolution, how you evolved the product, how you got feature requests through feedback from the users. I think that's also a really, really good lesson. Not over engineering things, but also, not creating features that you think someone is going to use. When your product is being used, you will get those feature requests back.
Sure. Well, let me tell you, I built many features nobody used. I allowed you to attach an inbox to your private email, your personal email. You would always get forwarded to those. I allowed you to come to the site and your cookies would remember the last emails you'd logged in. I allowed you to pin inboxes. I had all kinds of features that nobody cared about for a lot of this. But yeah, once the QA teams took over, it became very obvious what the users were using it for. In fact, one of the things we're working on right now is the Mailinator site. We have a redesign of the site coming up, and redesigns are absolutely traumatic because the site is automated through Selenium thousands of times a day. So the moment I change the design, I break tests all over the world. So what we're building is an additional version of the site that'll be equally available, that will be a very dead simple design that will never change. And it'll be optional to go there, but it's going to be built. Usually people try to prevent their site from being automated or scraped. Well, for our customers, we're trying to enable that. So that base level version will be there, and they can put in their Selenium tests and it'll never change. So that is exactly it. Our customers sort of told us where to go, and the product evolved right along with the tech. And just like any good coder on a side project, I wasted way too much time building stuff I shouldn't have built that didn't matter, but I had a blast the entire time. So.
Yeah, no, I can definitely see this product being used a lot for quality engineering teams.
Sure.
So when was the so this is, you said 17 years in the making, and but you start monetizing, I don't know what year. I mean,
Yeah. Well, that's
were
a good
you
question, right? Hey, Doug.
self-financing this?
We never got financing. It was never any. And keep in mind, I was full-time job for 16 years of this, so it was always a side project, and it always paid for itself. In the beginning, there was not even ads, I don't think, and I had a Server Beach coupon that if I got a referral, I'd get 2 free months of server, and I put that up on the Mailinator site, and I think I had like 4 years of free server, so it never cost anything there. I was running ads for a while, and eventually, and they were making a little bit. I mean, never anything interesting. Ads don't make anything. And then they banned me from Google. Google banned my ads. And then a year later, I went to work for Google and found the person that banned me. And said, "Why'd you ban me?" And they said, "Well, you can't show ads next to email because they're private. Emails are." I'm like, "These email aren't private." And I convinced them to turn me back on. And then ads were on for 10 more years. And then Google banned me again, and I don't work there anymore, so I'm done. And that's fine. Who needs ads anyway? They weren't worth it. But I think they started monetizing in about 2013 or 14, slowly and surely. And it slowly picked up, but we never received financing, and the company supports itself now and supports people working for it and all the rest of it. It was a slow roll. But and again, it wasn't a full-time project until basically recently. So, but now, yeah, it's a business.
Cool. We have a question from Doug Jones, which
That's the one you just asked.
Yeah, well, he's saying, thanks for a great presentation, Paul. When did you start doing private paid Mailinator subscriptions?
Yeah, like I said, about 2013, 2014, I think. Maybe 2012. I'm not sure. Somewhere in there.
Cool. Okay, well, while we wait for any other questions, why don't we go ahead and we're going to do the raffle in the meantime. So, Paul, do you have
Sure, I do.
A question for the attendees? And whoever answers first gets a 1-year license for a JetBrains Pro.
There's two possible correct answers. How many emails a day did Mailinator start to crash constantly, or how many emails a day did it stop because the network card was saturated?
Oh,
big round numbers, very big round numbers.
I love that piece of the story, because I mean it's where is your bottleneck, and sometimes I mean the fallacies of distributed systems, right? I mean,
yeah,
network is liable, that throughput.
Always going to have a bottleneck. Just where's the next one, right?
Yeah.
Nobody's getting that question. I mean, I can make it easier.
Yeah, let's try a different one.
Okay.
Yeah,
you don't get this one. What year did I start Mailinator?
That's an easy one, guys.
That's an easy one. Hey, 800K. That's right, Sheldon.
Oh, yeah.
That's 800K. That was the first question. That's right.
Cool. Well, Sheldon, if you can reach out to me on info@cltjog.org, so you can send me I'll get your email that way. Don't use a Mailinator email, because
don't use a Mailinator email.
Yeah, because everyone will get your license.
Thanks to all the Lending Tree dudes that I used to work with that showed up for the talk. I appreciate it. That's exciting.
Okay, well, while we wait, in case there's any other questions, I'm just going to quickly advertise our next event. Yeah, the next month, October, we're going to have a really good session with Jonathan Villa. He works at Red Hat, and he's going to talk about migrating Spring Boot applications to Quarkus. So Quarkus is a new framework to create really, really fast Java applications. So this is our on the next one. So if you anyone interested, please reserve your spot. And so let me stop presenting this. Check if we have any other questions. If not, then, well, I just want to thanks again, Paul. Really appreciate it. This was I saw this talk the other day. I mean, when you gave it, I don't know where, there was a recording somewhere, and I say, oh, this is pretty cool story about architecture and product evolution. So I really enjoy it, and the second time was the same experience.
Awesome.
So
Thanks for having
appreciate
appreciate it.
and thanks everyone. Well, we'll see you on the next one. Take care.
Bye bye.